Hi you guys, welcome back to my channel. I post new videos almost every week and be sure to subscribe and smash that like button. Um, just kidding, I can't even do it with a straight face. You didn't even get to see me smile though. Is that how you do the YouTube? I don't really know. I'm doing the best I can. So let's get into another video, you guys. This is where things start to get a little cray-cray. And this is also where you will see things again in not 10th grade, in ninth grade, while you do 10th grade math. The stuff I'm teaching you right now repeats so heavily in the beginning of next year. So that is why it is very important that you are watching these and trying your best and asking questions when you have them. So we're just going to jump into some examples of solving equations with radical exponents. The stuff that you learned in the last video will relate, but it's going to be different because we're going to be making equations and solving and stuff. So let's get into it. Here's the first problem that I'm going to do with you guys. We are going to try to solve for x. That is our goal. This gets pretty complex. The place that you want to always start is by simplifying a single side of the equation as much as possible. So like, for example, the right side, I don't want to simplify. I don't want to actually do 3 to the 9th power. In this unit, we like keeping things with exponents, and you'll see why in a minute. But on this left side, there's definitely some stuff that I can do. Going back to the first video from this week, talking about exponent laws, when I see this, what I see is the product rule. And the product rule allows me to combine these two things together and rewrite them with a single base. Because they both have a base 3, I'm going to keep my base and I'm going to add my exponents. Even though my exponents are not pretty, we will not judge. Okay, so what I just did is use the product rule to write this with a single base, and I used the product rule. I added my exponents together. Now, we want to simplify this further. At this time, I can't add these two fractions together because they have different denominators. I mean, you can even write this off to the side if it helps you. If I just gave you a problem like this and said, add those, children, you wouldn't be able to because the denominator is different. We need common denominators to add. Therefore, we have to do something before we can add them together. So I'm going to continue doing it over here on the side. The common denominator that I would want to use is 6. So I need to rewrite them each with a denominator of 6. In order to turn 2 into a 6, I need to multiply by 3. And I have to do the same thing on the top. X times 3 is 3x. And then same thing over here. To make 3 turn into a 6, I would multiply it by 2. And then I would need to do the same thing to the top, giving me 2x. So to summarize that step that I just did, all I tried to do is get common denominator. I knew it had to be 6, so I had to multiply my numerators by the same thing. This is what that turns into. Why don't we just rewrite it? Might as well. Got nothing but time. Can't leave the house. Dun, 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 dun. There we go. Okay, that's better. Now I can add those together because I have a common denominator. So let's go ahead and do that. Still have a base 3. With this fraction, remember when you add fractions, gosh, it's probably been a long time since you've had to do that, but I'm not going to go over fraction rules. Keep your denominator the same. I had 3x on top and 2x on top. Putting those together gives me 5x equals 3 to the 9th. This is looking much cleaner already. In the beginning, there was a lot of stuff going on, very overwhelming. Now it's looking cleaner. And we can continue to solve for x. Here's where things get cool, you guys. So I'm going to kind of slide down here. Because our bases are the same, and this only works if your base is the same, because those bases are the same, I know that these exponents have to equal each other. right? That's what the equal sign means. It means that whatever's on this side has to equal that side, which means I need whatever's on the left side, and I don't know yet because right now there's a variable, but I need it to equal 9 no matter what. So now we just have a little simple equation that we can solve, and that's going to get us x. So I'm just going to quickly kind of go through that. To solve for x, to isolate the variable, get the variable by itself, I need to get rid of the 6 on the bottom, which is currently being divided. Opposite of that is multiplying both sides by 6, giving me 5x equals, for a second I forgot how to multiply, 54. Okay, next step would be to divide both sides by 5. Therefore, x equals, and since I can't divide it evenly, I'm just going to go ahead and keep it 54 over 5. And guess what, y'all? That's the answer. I actually kind of think you guys are going to like these problems better than the ones we were doing yesterday, even though that was like an intro to all of this. So yeah, x equals 54 over 5. And let's go ahead and go on to another example. All right, we've got a problem very similar to the last one, incredibly similar. So I suggest pausing the video, seeing if you can work this out without me, or at least try to stay a step ahead. Our first job when we are trying to solve for x would be to simplify as much as possible. I'm going to go ahead and rewrite the left side here with a single base. So since it has the same base, and remember that only works if it does have the same base, sometimes it won't, and we'll get to problems like that. So I'm going to keep my base and add my exponents, and the reason I'm adding them is because I'm using the product rule. X over 4 plus x over 6 equals 2 to the third. So go ahead and pause again, see if you can figure out what to do next. The next step would be to add those together. I can't add them how they are because the bases, I have all my terms mixed up in this unit. The denominators are not the same. So I'm going to go ahead and write it over here. If you can do it in your head, go for it. Be my guest, you guys. So that is what I need to do right now. Can't do it because my denominator is different, but I think I'm going to use 12 as my common denominator. In order to get 12 from 4, I would have to multiply by 3. So I'm going to do that on the top as well, giving me 3x. And to get 12 from 6, I would times it by 2. I just realized that the dot is much more clear than me writing an x. I'm going to multiply this by 2, giving me 2x. So I'm going to go ahead and rewrite that over here. 2 to the 3x over 12 plus 2x over 12 equals 2 to the third. So next up, let's add those. I've got 2. And then I'm going to keep my denominator 12 and add the numerators, giving me 5x. And that's equal to 2 to the third power. Now, just like the last one that we did, we need to solve for x. We have the same base, so I know that whatever I plug in for x has to make this exponent turn into a 3. Because that's what I need it to be equal to. So we're going to actually ignore those 2's to finish this problem and write it like this. To solve, it's very similar to the last one. I'm going to start by multiplying both sides by 12. That's going to go ahead and give me, those go away, a 5x equals a 36. And then the last step, divide both sides by 5. X equals 36 over 5. It's weird because we're not used to, first of all, getting ugly fractions as answers, and this is something that is very new to all of us, but that is how you solve them, which means if I were to take that 36 over 5 and plug it into my very original problem here and here, and then simplify all. It would be a lot of work, but we would end up with 2 to the third power, which is 8. So the reason those problems worked out so nicely was because the base was the exact same. So if this 27 were a 3, I would be able to just take those exponents and set them equal to each other and solve for x. However, because it's not a 3, I can't do that. So we have a step before we get to start solving the equation. The only way that this problem will work for us is if we can somehow turn this base 27 into a base 3. So my question for you is, how can I rewrite 27 with a base 3? And hopefully you guys will be able to come to the conclusion that I could say 3 to the third power. And I hope that we can all agree that 3 to the third power is the same thing as 27. Now what that allows me to do, and I'm going to rewrite this here, rewrite my whole problem. What that is going to allow me to do is now set these two exponents equal to each other and solve for x, which is great because we wouldn't have been able to do that before. So before we set them equal to each other, I'm going to go ahead and distribute this 3. A really common mistake people will make is when they convert their 27 to a 3 to the third power, they won't use parentheses. Remember, I said I'm the parenthesis queen. You have to use parentheses, otherwise you won't remember to distribute that 3 to both of those numbers. So this becomes 3 to the 3x minus 12. I got these numbers from distributing my 3 here and here. The right side's still the same, didn't have to do anything on that side, so that was cool. And now I have the same base. I can just set those two exponents equal to each other because I know I need this to be equal. That's what that equal sign means. So let's go ahead and set them equal to each other and figure out what does x have to be in order to make this true. You guys should be able to do this. We did this quite a bit this year, solving equations. Got to get all the x's to one side. I'm going to take away 2x on both sides, giving me x minus 12 equals negative 6. And then finally adding 12 on both sides gives me x equals 6. Ta-da! We did it. That wasn't too bad, right? I actually really like this stuff. I think it's really fun. You guys probably think I'm crazy for saying that. So x equals 6. What does that mean? That means that if I plug in 6 to both of these x's, I will end up, after simplifying, with the exact same number on both sides. Try it. See if it works. Spoiler alert, it will work. All right, get a load of this problem. Now things are getting really crazy, but as you'll see in just a few minutes, this problem is not as scary as it may seem. I know now, after that last problem, that something that's really important is to get the same bases somehow. So I know that regardless of whatever happens after, I have to end up having the same base here and here. So I need to start thinking in my head, what number raised to what power can give me 125? And what number raised to what power can give me 25? And is there a number that has the same, that will do that? From my years of teaching math and, just my old age, I know that these numbers have a 5 in common. If that's not something that stands out to you, you are going to have to use the guess and check method until you start learning your exponents and memorizing them. And that's going to be more difficult for sure. But when you start solving more and more of these, it's going to start making more sense. So we are going to think base 5 right now, okay? So I want to rewrite 1 over 125 with a base 5. Now, I need to figure out, how did a 5 with an exponent turn into a 1 over 125? The first thing I notice is that the 125 is on the bottom of a fraction. and I want a 5, like a regular, good old-fashioned regular 5. So I know that my exponent must have been negative, because the whole cross the line, change the sign thing, with a negative exponent, that's going to make me have to move this to the bottom, which it is here. So that's good. Next thing I need to know is, what number would I use to get from 5 to 125? Well, 5 times 5 is 25, and 25 times 5 is 125. So 3 would be the magic number. So like I said, that's kind of a lot. If you don't have exponents memorized or fresh in your head, that is going to be something that's going to be tricky for you to do until it starts getting more familiar. So be patient with yourself, okay? Get a calculator, guess and check, and try your best. And then I'm going to go ahead and write this. Now I have to do the same exact thing with this side because I need them to have the same base. Base 5. Now this one will be easier because we already went through that process. Again, it's a fraction, so I know that that exponent was negative, and to get a 25, I would have to square it. My goal here is to figure out, what can I write here that's the same as this, because 5 to the negative second power is indeed 1 over 25. That's what I was trying to figure out. Now I have the same bases here. That is good. That is going to help us. So that's the first step. Very, very tricky, I know. Next step, I need to distribute or use that power rule, because I've got exponents being raised to exponents. So I'm going to use the power rule to simplify this more. The goal is to make things as simple as possible, because when you look at that first original problem, like, holy moly, it's overwhelming. There's so much going on. So we're trying to make this as simple as can be. So power rule tells me that I can take an exponent being raised to an exponent, which this is, and I can multiply them together. So negative 3 times negative x over 2. Now, this is something that you guys can probably, I don't know why, there we go. This is something you guys can probably do in your head, but if that's something that you might struggle with, go ahead and write it on the side. Negative 3 times negative x over 2. I know that to multiply fractions, you just multiply across, and that should make it easier. This would give me 3x on top and a 2 on the bottom. That looks much nicer than what was there before. This one's a little more tough even, because I'm going to have to do some distributing. Let me write it off to the side so you can see what it looks like. This would be negative 2 times negative x over 3 minus 2. I need to distribute that negative 2 is what I'm trying to show you right now. This part is very similar to what we did up here. It would become 2x over 3. And then negative 2 times negative 2 is positive 4. So this would become 5 to the 2x over 3 plus 4th power. So each step should get us looking a little bit more simplified. Now I have a problem that I can totally solve. Before, I had different bases, I had x's everywhere, I had parentheses, I had negatives, it was crazy. Now I have something that's quite beautiful. Same base, which means I can go ahead and rewrite this without that 5. Just like the other problems. Wow, that's a lot nicer. Now I can solve for x. There's a lot of ways that you guys can solve this for x, not just one right way. But one thing that I taught you quite a while ago, was that if you want to get rid of fractions when you're solving an equation, you can multiply the whole equation by a number that those denominators have in common. So I'm going to multiply everything by 6, and here's why. When I do this, I'm going to end up being able to get rid of my 2 and 3 as denominators like this. Let me use red for this one. Actually, yeah, I'm going to go ahead and rewrite that as times 6 times 6 and times 6, just so that we can really see each one individually. Okay, so for the first part, when I multiply by 6, I can cross cancel this 2, turn it into a 1, and the 6 and turn it into a 3. That would give me now a simple 9x equals. When I multiply this part by 6, I can cross cancel the 6 and the 3, giving me a 2 here and a 1 here, and an answer of 4x. And then this part's easy peasy, gives me 24. That to me looks so much nicer than what was written. You could have solved that with all the fractions and all that stuff, but me personally, I need to see equations like this because that really overwhelms me. So use that trick of multiplying by a number. It's helpful. Make sure you don't forget that even the single numbers like that have to be multiplied still. Now we can solve this very easily. I'm going to go ahead and subtract 4x on both sides, giving me 5x equals 24. And last step for this whole crazy problem is to divide by 5. I end up with 24 over 5. Whew, man, that is one long and crazy problem from that very beginning all the way down here. So what our answer means is if I were to take I can't even talk after all that, 24 over 5 and plug it into these x's, I would never want to do that because it would be very messy, but I would end up getting a true statement and something that's equal to each other. So it's a lot of work to get to the final answer. These ones are probably the hardest types of problems that you're going to see. But rewatch this example. When you guys get problems like this, rewatch this and just go step by step with me, and hopefully that will help you. Because this video is already at 22 minutes, I'm actually not going to do any more examples. You guys have the ability to rewatch this, so I hope that helps you when you're doing your Math Excel. There are going to be problems that are very straightforward like yesterday, and then there will also be problems like these ones where you're solving equations. Go slow, rewatch my examples, solve it with me, like take your new problem and watch me solve these old problems and just go step by step and let me help you through it via YouTube. Like I said, these are the tough ones, and I'm telling you guys, you will see questions just like this in the very beginning of Math 2 Enhanced or Math 2. So it's so important that you take the time to practice this, even though it's difficult. Push yourself. It'll give you something to do while you're bored in quarantine, right? I think that's all I have to say. Good luck. I'm here if you need me. I miss you guys like crazy, and I will talk to you soon.